Start it. So we're doing limits, but this is section 2.3. It's called limit laws. Limit laws. But the idea is we're going to be doing, I guess you can call it limits with algebra. Okay. So in the last section, you guys had a bunch of graphs and you had to eyeball the graph and say what the limit is. So in this section, we'll be able to do limits without any graph, right? We could just look at the function and just using the function, we can compute the limit. We don't have to graph anything. We'll know everything just from the function. So here's the idea. So just as an example, we could ask, what's the limit as x goes to 2 of x squared plus 5? Okay. Now, I know what you're thinking, right? Limit means left and right. That's good. Good. If you're thinking that, that's good. There is a shortcut here. Yeah, limit does mean we have to do left and right. Now, the idea of this section is we're not going to do that. There's a shortcut. And here's the shortcut. How does it work is we'll be dealing with, at least the first part, with continuous functions. Functions are called continuous. This function f of x. I won't go through the mathy definition, right? The real definition you don't want to know. So I'll just make it somewhat reasonable. The more reasonable definition of a continuous function is has no jumps, what are called jumps. Okay. Meaning the curve just keeps going. It doesn't all of a sudden jump to a different function. It doesn't all of a sudden jump points. So what's a continuous function? Right? There's no jump. So we say f of x is continuous at a, right? It's not jumping. But what's not a continuous function is when you look at a. So you might have something like this where it jumps at a. Or maybe it's undefined. So this is not continuous. Not continuous at a. Right. What else is bad? Meaning everything that we saw in the last section is pretty much all the bad stuff. Right? Not continuous. Okay. You guys see what I mean? So continuous means it's not jumping, right? It's just smoothly going from one to the other. So if your function is continuous at a, okay, then the limit as x goes to a of f of x, right? Limits are predictions. Well, if your function is continuous, there's nothing to predict. We have full information. We know exactly what's going on left and right. And what is the function doing? It's giving you the y value, f of a. The limit is f of a. So you don't have to do it. You just plug it in. Just plug in the value and you're done. You don't even have to do anything as long as the function is continuous. So just plug in a. Right? So our example here, right? We're saying now x squared plus 5 is a quadratic. There are no jumps, right? The only time there are jumps, you'll know there's a jump. It'll be a piecewise function. It'll be undefined somewhere. Being undefined is considered like a jump. It's not continuous. But if it's a perfectly nice, pretty function, right? Someone want to try what's going to be the limit? You just have to plug in 2. Right?
9.
9. That's it. That's it. What was your name?
Matthew T.
Matthew T. Right, like Matthew's saying, you just plug in 2, right? This is just 2 squared plus 5. Right, it's continuous. I don't have to do left and right because that's what a continuous function does for me. Normally I have to do left and right, but I skip all that. How does that sound? Right. We like continuous.
Yeah.
Continuous is good. Okay. All right, so let's do more examples. Okay. So let's do another example. So remember, as long as it, looks continuous, like the function's not doing anything weird, you can use this. So this example, right? So the limit x goes to 0, x minus 3, x minus 6 over x. Okay. Now, is this function continuous or is it undefined somewhere? It's undefined somewhere. Where?
0.
At x equals 0, right? It's undefined. So then we can't really plug it in. Like if we tried to plug it in, well, then we'd get -3 times -6 over 0. That's our c over 0 case, right? That's from last section. Then we have to do like limit from the left, plus or minus infinity, limit from the right, plus or minus infinity. Then we could maybe get an answer, but not continuous at x equals 0, right? Because it's just undefined. But so I'll just say use c over 0 case from the last section. But what if instead I do the limit as x goes to 4 of x minus 3 over x minus 6 divided by x? Is there anything bad when x equals 4? Is 4 in the domain? Right? Is it okay to plug in 4?
Yes.
Okay, so that's how you're going to know it's continuous, because it's okay to plug in. Just plug in 4 and nothing bad happens. Right. So what's the limit? What's our final answer? Oh, we could just plug it in. Right. Spell out the entire algebraic expression, I guess, so that it's not one number. So if I plug in 4, I get, in the numerator, I get 1 times -2 divided by 4. And that's it. That's it. Right? Because it's continuous at 4. Continuous at 4. At 4. All the familiar functions that you guys have are continuous. So e to the x, Matthew T.
Yeah. Why didn't you simplify the tool?
If you want to. If you like simplifying, go for it.
So we can leave it.
Yeah, I'm going to be leaving them.
It's fine.
I don't simplify unless there's a purpose. But if you guys like to simplify, you could do that work. Rachel. Oh, this is a new problem. Yeah, it's just a new problem. Yeah. Just to point out the difference, that if they ask you limit x goes to 0, it's not continuous. So you can't just plug in and get an answer. You get a nonsense answer. It's c over 0. So then left, right, it's going to be positive or negative infinity. If they don't match, it'll be d and e. But if they instead ask you x equal to 4 and you're worried like, oh man, like, is this a C over 0 case? The answer is no, it's continuous at 4. You don't have any work. You could just plug in x equals 4 and you'll be done. Yeah, so does that answer your question? Yeah. Yeah, so this was like a new problem. Most functions that you guys are used to are all continuous, e to the x, ln of x, absolute value of x, any polynomial, rational functions. Rationals are polynomials over a polynomial, like this was a rational function. Rational functions, but I'll say within their domain. Okay, so this is a rational function, so a limit with x equal to 0 would be a problem. But limit of any with any other x except for 0, you can just plug it in because it's continuous. So you guys could use that. And in general, plugging in is a good idea because just like in this case, when you guys plugged it in, we got C over 0. We know what to do with C over 0. It's the infinity, negative infinity thing. We plug it in, we got a number. Okay, that's continuous. So either way, we know how to get an answer. Either we'll get the C over 0 right now, or we'll actually get a number and then we're done. Either way, we're done. So plugging in will help us either way. Okay, just have to know what to do with it. Okay, so I'll even write that down. When asked to do a limit, if plugging in the value gives you a finite answer, I guess it's all good. Then it's all good. As long as you're getting a number. Finite answer means getting a sensical number. Okay. So as an example, limit as x goes to 4, cube root x minus 3 over x squared plus 1. So just try it. Plug in the number. See if you get something sensible. You know, something reasonable. Someone else want to try it? What's your name? Raphael? Okay. Yes. So what do you get?
1/17.
1/17. So what did you do?
I plugged in 4.
Plugged in 4.
One is
Mhm.
then
16 plus 1. Like that. Good. You just plug in. If you get like something like 0 over 0, you have to do something else. If you get something like C over 0, like we had in the last section, you have to do something else. But if you're getting a number out of it, then you're dealing with a continuous function. So there's not much going on with the limit. Okay. There is a tricky one. The trick question they could ask you is, this one's a little bit tricky. Radical x minus 4. Okay, so this would be a trick question technically. So the thing is, what's the domain for this function, radical x minus 4? Only x values that, Raphael?
Values are greater than 4.
Right, x values that are greater than or equal to 4. But remember, a limit means left and right. That means even values to the left of 4 have to detect a pattern. But I'm not allowed to plug in values to the left of 4. They're not in the domain. So for this, I can't just plug in 4. Automatically, it's D and E. D and E. Yeah, I don't have values. Right. In order to use this trick of continuity, the function has to be defined to the left and the right of that value. Yeah, so radical x minus 4, technically it is continuous, but at 4, we don't say it's fully continuous because on the left of 4, it's not even defined. So it needs to be defined left and right. Yeah, Matthew?
Let's just say it's asking for 5,
Yeah,
that would be fine.
that's right. Matthew's saying, what if it's asking for 5? Yeah, plug it in 5. 5 is perfectly fine. Just plug it in. In fact, if they ask you limit as x goes to 4 to the right, that is sensical. 4 to the right is sensical. And this is continuous as long as I'm to the right of 4. You could just plug in 4. Because at least this function makes sense to the right of 4. And this function, a limit asks for both sides. So if the function doesn't even make sense on one side, then it's just automatically D and E. Okay. That's a curveball. Like, I don't know. I don't think I would ask that. WebAssign probably does ask that, just so you know. Yeah. Let's try one more. Limit as x goes to -1. X cubed plus 4x squared minus 3 over x squared plus 1. Okay, let's try that one. Right. First thing we just do, we just plug it in. What's the denominator? -1 squared is 1, plus 1 is 2. Okay, so nothing wrong with the denominator. Numerator, -1 cubed, I guess, -1 plus 4 minus 3. So what's the numerator? 0 over 2, which is just 0. It's okay to have 0 in the numerator. Denominator is a problem. 0 in the numerator, just 0. Any questions on this? Continuous, does this make sense, guys? So you'll plug in first. Your first step, just plug in. Right? You might get a sensical number, and you're done. That's the answer. If you get 0 in the denominator, well, you have the previous section. So it might be a C over 0 case. And 0 over 0 we'll cover a little bit later today. Okay, so here's a theorem. So say that the limit as x goes to a of f of x and limit as x goes to a of g of x exist. Okay. So what does it mean exist? You know, left and right match up, give you something. And then c is constant. Okay, so you have a couple of properties that you have. If you want to take the limit as x goes to a of c times f of x, you could just factor the c out of the limit. Right, so limits allow you to do algebra just like you would in an algebra class. Okay. Okay, so if c times f of x, just take the limit of f of x, multiply by c. Just whatever algebraic operation you have, it stays with the limit. And this works for a lot of things, so like limit as x goes to a, f of x plus or minus g of x. Okay. You could just do each limit separately. You could do limit of f of x separately, plus or minus the limit of g of x separately. Okay. It lets you break up the pieces, basically. Number 3, limit as x goes to a, f of x times g of x is going to be limit x goes to a of f of x times limit as x goes to a of g of x. Same thing with division. Limit as x goes to a. If you have f of x divided by g of x, then similar thing. You could just do each limit separately. You could do the limit of the numerator separately, divided by the limit of the denominator. Okay. Just to keep in mind, as long as you're not dividing by 0, not 0. So what does all this mean? It basically lets you do what you would do anyways. Here's what I mean. Here's a little example. So example, what would a question like this ask? They would say, suppose limit as x goes to 3 of f of x is equal to 8, and limit as x goes to 3 of g of x is equal to -5. So you have two limits. And then part A, what is the limit as x goes to 3 of f of x plus 6 g of x? So I have these two pieces. Can I combine them? So all these things are telling you is what you would expect, that you could replace this by the limit of f, which is what? Limit of f is 8. And I could replace the limit of g with -5. So just even without this theorem, like what would I expect? I would expect 8 plus 6 times -5. Okay, so that's what you would, I guess, sort of guess. This theorem just means you're actually allowed to do that. So I can do limit of f of x plus, now the constant you could factor out. See, the constant rule gets factored out, plus 6 limit of g of x. Okay. So limit of f of x gets replaced by which number?
8.
8. Plus 6 times limit of g gets replaced by -5. Okay. Does that make sense, guys? See what we did? Yeah. So does writing the theorem make it more confusing?
Yes.
Okay, versus just asking you to do this? Okay, so really what the theorem is telling you, that if I asked you to guess the answer and you just guessed, replaced f by 8 and replaced g by -5, the theorem is basically saying your guess would be correct. That's all it's saying, that you're allowed to do that with limits. Okay. So even if this confuses you, if this makes sense to you, that limit of f gets replaced by 8, g gets replaced by -5. Okay, then that's all you need. If they ask you for limit as x goes to 3, f of x plus x over g of x. Okay, now this theorem says I could do each piece separately. That means every little piece, what will f of x get replaced by? 8. But now the function x is a continuous function. So what's the limit of x if x goes to 3? What will x get replaced by? Just 3, right? How do we do that? We just plug it in, right? Because it's a continuous function. Continuous functions, I could just plug it in. So if it was not x, but it was, let's say, cosine of x, what would cosine of x get replaced by? Cosine of 3, continuous. What does g of x get replaced by? -5. So when you guys do this, that's what it's saying. I could do each piece separately in this theorem. It's 8 plus cosine of 3 divided by -5. Yeah. Any questions on this? Yeah. Good, good. What was your name? Sanjita? Yeah, but like Sanjita is saying that what's important here is that the limit has to be the same value. So limit as f of x, x goes to a, and also this one, x goes to a. So if this was like limit of f of x, x going to like 5, and this one was like x going to 4, this wouldn't help you, right? Because we just don't know the limit of g of x as x goes to 5. They only give us the limit as x goes to 4. So it's not like the theorem would be wrong. It would just give us no information, right? Because what would happen is you would apply the theorem, but this one you might know, they might give it to you, but then you might just not know this because they only gave you like the limit as x goes to a plus 1, a different number. But they won't do that, thankfully. Yeah, Matthew.
It's like it's only going to be like this situation when it's the same number, right?
Yeah, exactly. Yeah, otherwise, it's not that it's like something complicated. It's just you just give up on the problem because it's just not enough info. Like in this problem, like let's say they gave me the limit as x goes to 2 of g is -5. So what could I do? Well, the f of x, yeah, will get replaced by 8. The cosine could still be replaced by cosine 3. Just the denominator, I'd have to leave it as limit as x goes to 2 of g, which I don't know. Right? It'll just be information I don't know. So that's why it's not such a good problem. So they'll give you the full information. You'll be able to compute it. Okay, good. Other questions? Yeah. It's okay. Let's see. Another one, this one doesn't come up so often, but it's basically composition, that all these rules that we have of being continuous works with composition. So I could take the nth root of a function, limit of f of x, and that's going to be equal to the nth root, and I could put the limit on the inside. X goes to a of f of x. So in our example, better not have thrown it away. Okay. So in our example, what if they asked you to do the limit as x goes to 3 of let's say, fifth root of f of x, what this rule is basically saying is that the fifth root is continuous. It's a continuous type of operation. So I get to put the limit on the inside, meaning I get to replace f of x by number? By 8. That's what it's saying. The final answer is what?
Okay.
Fifth root of 8. Just remember, don't forget the fifth root. Like, keep it there. Okay. Is this easier to understand than this nonsense? All right. All right. That's the mathematical nonsense. That's our trade. This is what we write in our papers. But unfortunately, people don't like that. So we also do this. Okay.
So from what I can like see, bring that for all the president here.
Oh, what is it? What's the question?
If you're at like the f of x and ga of x, right? But if you put the limit like x towards a,
Yeah.
limit for both of them, or every single one that would appear there.
That's right. Yeah. Yeah. Just go towards both of them. That's right. All right. So it's just basically doing what you're used to. So even without this theorem, you know, it might even be easier just to ask you a question rather than give you a theorem. Is, you know, limit of f of x goes to 3, limit as x goes to 3, let's say of e to the f of x. Okay. So the idea is e of x is a continuous function. So I'm composing e to the x with f of x. So that means I could put the limit up there with f. Wherever you see your function, I could put the limit there because e is continuous. So the final answer is what? Yeah, Matt?
E to the 8th.
E to the 8th. That's it. That's what these theorems are allowing you to do. Okay, but mathematicians had to prove them so that you could do that. Okay? They already did the work for you. They already did the work. That's why in 2 seconds you could just write down the answer. Okay, does that make sense? Yeah. Not testing you on the theory, but you should be able to at least compute these. Okay. And again, if I did limit as x goes to 3 of x squared e to the f of x, again, all these limit laws are letting you do pieces, meaning I could do x squared separately. What's the limit of x squared? As x goes to 3, limit is 9. And then I could do e to the f of x separately, which is
8.
e to the 8. Okay. Yeah, absolutely.
So if it shows x, we just put like what the limit is going to, but then if it's f of x, we put what it actually equals.
Well, the thing is that x squared is an explicit function. So that this one, you're computing the limit itself. You're actually doing the limit. See, the thing is here, you're also doing the limit of f of x, but they already did it for you. Meaning, so really it's the same thing. It's really like limit as x goes to 3, x squared times e limit as x to the 3 of f of x. So you are computing both limits. You are computing y values of 2 functions. But this one, they didn't do it for you. So you have to do it. You have to plug in 3. This one, they gave you the answer. So that's the only difference. You're really doing the same thing. Just one of them, the problem gave you the answer. One of them, you do it yourself. Is that answer?
Makes sense.
Okay. Now, piecewise function. Let's do f of x is equal to x squared plus 6 for x less than 2. Then it's equal to 10 for 2 less than x less than 3. then it's equal to x plus 1 for x greater than 3. All right, part A. What is f of 2? It's f of 2. Right, piecewise function means it's a combination. It combines 3 different functions. So you have to know where to plug in, first, second, or third, or neither, or yeah. Go ahead. Undefined, why? Yeah, why? Why is it undefined?
X cannot be 2.
Right, notice the domain. Does x equal 2 anywhere in this domain here? No, so like Safael is saying, f of 2 is D and E. There is no f. Does that make sense, guys? It's not in the domain. Okay. Part B. Now the limit as x goes to 2 from the left. Okay. Now, since your function has multiple pieces, you have to use the x value that they're giving you to figure out which piece you're using. Right? This is 2 from the left. Now stare at the function. Only one of these 3 is 2 from the left. Think about it. Take a second. Then we'll take a vote. Okay, who thinks 2 from the left is the first function? Who thinks 2 from the left is the second function? Who thinks 2 from the left is the third function? Who's not sure what I'm asking? Like, what is he talking about? Left, right? It's one function. Why are there 3 functions? Okay. Yeah, remember, this is a piecewise function. Yeah, remember, 2 from the left means numbers like 1.9. So numbers like 1.9 means we're using the first function. So you guys have to, x goes to 2 from the left equals x squared plus 6. Okay. Now don't plug in 1.9. I see students plugging in 1.9, 1.99. It's incorrect. This is just to figure out which piece we're looking at, right? Because limits are a pattern. So to get the pattern, we need to know which piece we're standing on. Now, x squared plus 6, is that continuous? Now ignore everything else about this problem. Cover it up. I'm just asking you, x squared plus 6, is that continuous? It's continuous. What do we do with continuous? Just plug it in. What's our answer? 10. So we just plug in 2 squared plus 6. That's right. 10. Any questions on that? Yeah, Matthew.
So 2 squared plus 6 equals 10. But like, let's just say we look at the top
Yeah.
where we have these. So it's like 10 when x is
Oh, you mean the second function is 10 between 2 and 3? That's right. That's true.
thing.
But that's okay, because at least going from the left, without even moving to the right, this function is approaching 10. And then when we move to the left of 2, sure, it'll become 10. So yeah, if I drew this, that means 2. If I look to the left of 2, I would get a 10 output, right? So that means I'm getting something here with a hole because it's undefined. Now, what happens after 2? Anything goes. It could be anything you want. It happens to be that after 2, it's 10. So if I really wanted to graph this, I would graph something like this. But it could be anything after 2. Okay. This is just what's happening to the pattern to the left of 2, going towards 2. Yeah, good question. Yeah. That answer it? Yeah. Okay. Why don't you guys try? What about you guys try limit as x goes to 2 from the right? And then how about you guys do limit as x goes to 3 from the left? And try limit as x goes to 3 from the right. Okay, and just for the heck of it, do limit as x goes to 3 as well. Why not? Okay. Remember, piecewise functions, whenever you do a limit, only one piece is correct, right? If there are multiple pieces that are correct, that means it's not a function, right? A function means only one piece for those x values. Okay, so 2 from the right, figure out which piece. 3 from the left, figure out which piece. Okay. And when you do 3 from the left, you should be thinking of numbers like 2.9. Okay. Give you guys a moment.
So one. Still one.
Feel free to work in groups. Ask your buddy. See, there are 4 parts. Does anyone think they got one of the parts correct? Oh, no. At least one. At least one. At least one. Come on. Was it? At least 2? Okay. Let's see. 2 from the right. Which function did you guys think this was? Let's see. Oh, what's your name? Eddie? Yeah, Egid. Yeah. Which function did you use?
Second one
Good. The second one. Why the second one? Why the second one and not the third?
is coming from the right and
Yeah.
the 2.
Right. So, but the third function is also to the right of 2 because it's like for big values of x. But I mean, you are right. Does someone know why we have to pick the second, not the third?
Because it's very close to 2 and it's not larger
Yeah,
than 3.
exactly.
It's 2 point.
But I can say because we still have to limits are still staying close to 2.
You
not
can't
veering
go
off.
insanely.
Exactly. Yeah. So limit as x goes to 2 from the right. Second function of 10. What's the limit of a constant? We just plug in x equals 2. Constant function always stays. Is that Layla? The same, just 10. Right, stays the same. Yeah, constant function. It's easier to plug in. There are no x's. By the way, what's the actual limit as x goes to 2? Remember, actual limit means both sides match. But actually, they're both 10. 10, 10. 10, 10, yes. So, yeah, does that make sense? Like, see, the left and right match up. They're both 10. If one was not 10, one was 10.01, yeah, it would be DNE. But they are matching up. Someone else want to try 3 from the left? First, second, or third? Let's see. What's your name?
Cameron.
Oh, Cameron, yeah.
I use the second formula.
The second function or the third function? The second, how'd you pick the second one?
Because from the left would be greater than, I mean, from the right would be greater than 3, and we're looking at it from the left. So it's close to 3, but not over 3.
Good. Close to 3, but not over 3. So limit as x goes to 3 from the left. That means you should be thinking of numbers like 2.9, but don't go into the pitfall. Students plug in 2.9, and that means nothing. I don't like seeing that. Please don't plug in 2.9. There's always going to be a couple of people, but be the ones that don't. It's just 2.9 is in terms of the pattern that you're looking at, getting close to 3. So f of x of 10. Final answer, 10. Okay, 3 from the right. Let's see, is that see, we have Aisha. Did you pick the x plus 1? Exactly, x plus 1, and the limit is 4. Right. Good. Limit is 4. Do they match? No, so the final limit, D and E. D and E, yeah. Good. You guys see how to do these? Yeah? Okay. Okay, this one a little bit tougher, still okay? Okay? Okay. Yeah, so first you have to figure out which piece you'd use, but after you use the piece, you could just plug in because the piece itself is continuous. So let's see. I guess this is a trick question. It's not really a trick question. Not supposed to be. Limit as x goes to 4 of f of x. If I do limit as x goes to 4, which function would I use? First, second, or third? Third. And what would be the answer? 5. Okay. So they don't have to ask you for an endpoint. They could ask you a limit is valid to ask on any number you wish. Okay. The final case, okay. So we could do almost every single limit except for one, right? We have limits where you plug it in and you get a number, right? We also have limits you plug it in, you get c over 0, but c is not 0. So then you know it's infinite or minus infinite, right? The only one that we haven't done is what if both are 0? 0 over 0. I should highlight, even though this is the last case, this is actually the most important case. Most important case. The most important limits are going to be 0 over 0. Is anyone tempted to say that 0 over 0 is 1? Number by itself is 1, right? Well, the problem is with 0 over 0, the final answer could be anything. Yeah, there could be times where it's 1, but it could be rad 2, could be infinite, could be minus infinite, could end up being DNE. 0 over 0 is kind of an indeterminate form. That's the mathematical expression. It means it could be anything unless you're good at algebra. And with algebra, you could actually figure out what it is. So I'll show you how to do this. We'll start with an example. Limit as x goes to -10, x squared plus 3x minus 70 divided by x plus 10. Okay. Now, we always hope we get lucky, so we just plug it in and hope for the best. But if we plug it in, if we plug in -10, what's the denominator?
0.
-10 plus 10 is 0. And -10 the numerator, -10 squared is 100. -10 times 3 is -30. And then minus 70. Minus 70. What do we get? 0 over 0. What could it be? Okay. So what do you do? So the trick is do algebra until denominator, or I should say a piece of the denominator, piece of denominator cancels with numerator. Or I'll just say cancels. Okay, so it's very vague, but the idea is every single case of 0 over 0, right? It's already proven something called Taylor's theorem. I won't go into Taylor's theorem, but it's already proven for you that you could do just the right algebra so that things will cancel and we could plug in -10. It's already predetermined that there is algebra that could be done. Okay, it's already proven. So you can't come and say, well, I don't know what algebra to do, right? There is some algebra skill that will get you to the right answer to cancel. Yeah, Layla? Good, we could factor. So for these kinds of things, like Layla's saying, we could actually factor the numerator. Right? Factoring is always a good strategy. What are the factors that we need for -70?
X minus 7, X plus 10.
X minus 7 times X plus 10. Okay. Now you might think like, whoa, we got really lucky. X plus 10 in the numerator and denominator. Didn't we get lucky? No, no, that's the point of Taylor's theorem. Thank you, Taylor. He guaranteed that this would happen. He already proved that this would happen, no matter what, in a 0 over 0 case. So we didn't get lucky. It'll happen every time. Okay. Might not be factoring, might have another algebra trick we need. What do we do with X plus 10s? Cancel. Right, the slash. You're going to enjoy making those slashes. Get used to the slashes. Limit as X goes to -10 of X minus 7. Now what do? We plug in. Just plug in -10 and now it's continuous. The answer is -17. Okay, you guys see that? Okay, so very important. Once you know it's 0 over 0, you'll be able to do the algebra where at some point you'll slash. Okay. At some point you will be able to do the slash. There will be a cancellation. Okay. Questions on this example before we move on to the more examples? Let's see, I'll do limit as X goes to 0, X cubed plus 3X squared over X squared times e to the X plus 5. So try this out. First you plug in 0. And then if it's 0 over 0, that means you could do some sort of algebra. And if you need to take a break, I'll do this at 3:45. So if you need to take a break, take a break. See how far you can get.
Yes.
I get 16 from 16, but in with a sign like this.
Put it 14.5.
Yeah.
Oh. Fix that. Must have been a typo. Okay, I'll correct that. Okay, when we plug 0 into the numerator, what do we get? 0. 0 into the denominator, we get 0. What algebra could we do? Right, we'll try to factor. What could I factor out in the numerator? What's in both terms? X squared. Remember your name?
Jonathan.
Jonathan? Jonathan. Okay. X squared, and I'm left with x plus 3. X squared, e to the x plus 5. What could I cancel? X squared cancels. X squareds cancel, so all I'm left with x plus 3 over e to the x plus 5. So what do? I plug in 0, and what do I get?
3 over e to the power by
3 divided by e to the x plus 5, 0 plus 5 is 5, 3 over e to the 5, right? Yeah. You guys okay with that?
Yeah.
Okay. So if it's something like with polynomials, you'll try to factor. So with polynomials, you'll try to factor in a 0 over 0 case. Okay, so let's try another example. Limit as x goes to 49 of x minus 49 divided by radical x minus 7. Okay, so let's try it. 49 in the numerator is 0. 49 in the denominator is radical 49 is 7 minus 7 is 0. Okay, so that means something's got to work. Right? But there's nothing to really factor. There's nothing to really factor. So the algebra trick that you guys have learned, it's something called rationalizing. What we could do is remove the radical in the denominator by multiplying by radical x plus 7, top and bottom. Right, see, I'm allowed to do that because if it's top and bottom, they cancel, I'm just multiplying by 1. So I'm allowed to multiply top and bottom by the same number, or the same function. Okay. Right, so for things like this, you'll need to rationalize. Okay. I guess this time I'll go through the algebra steps once, but just so you see what happens. But what's rad x times rad x? It's just x. Rad x times rad x is x. Right? Important thing from algebra. Then I have radical x plus 7. I mean radical x times 7, so plus 7 rad x. And I have minus 7 times rad x, so minus 7 rad x. And then what's minus 7 times 7? Minus 49, like that. Okay. Now, when you do this, I recommend don't FOIL the numerator. We're trying to cancel the denominator. You'll make it harder for yourself if you do algebra in the numerator. The numerator, just leave it as is until you have to do something. So you might not even have to. A lot of times you don't. So leave it as is. Limit as x goes to 49. X minus 49, radical x plus 7. What could I simplify the denominator? Yeah, Matthew.
X minus 49.
Good, x minus 49. And what could I do with that? Right, Selena? What cancels out? So what am I left with, Selena?
Square root of x plus 7.
Right, square root of x plus 7. That's right. And now, can I just plug it in? Okay. As long as I get a number out of it, I'm done. So final answer, radical 49 plus 7. Okay, also known as 14. But I'll leave it like that just to maybe annoy some of you. Yeah. Is there a question? Yeah, you don't have to simplify. So even if you didn't know radical 49 with your calculator, hope is not lost. You just leave it like that. Questions on this? Yeah. You guys ever learned this little trick to rationalize? Helps you get rid of radicals. Helps you do algebra to get rid of radicals. Try one example like this, where you rationalize. Why don't you guys try this one? 3 minus radical x plus 9 over 2x. First plug in 0 just to see, is it a 0 over 0 case? Remember, you don't want to do extra work unless you have to. So 0 over 0 means there's extra work, but sometimes we're lucky. We could plug it in and we'll get a nice finite answer. Right? Then we'll be done. But try it out. Try to rationalize like we did on the other problem until something cancels. You guys didn't get the first step. The first step would have been this, top and bottom. Like this. You're gonna rationalize it. Okay. Last time we did it to the denominator, but here we could only do it to the numerator. But it's fine as long as we get either the numerator or the denominator to cancel, we'll be okay. Okay. See if you could take it from there. Who was able to get it? Was anyone able to get it? Yes. Anyone still getting still working on it? Okay. You don't have so many people that got it. Okay. So let's FOIL out, first of all, the numerator. So 3 times 3 is 9. So 3 times the positive radical and then 3 times the negative radical, those cancel. That's the point. What's radical x plus 9 times radical x plus 9? Minus x plus 9. Right, so this parentheses is very important. So I'll just have many students won't even get this step. Try to rationalize, and then they won't FOIL correctly. So be careful of the pitfall. Be very careful when you're FOILing. Okay. If you have more questions on how you FOIL here, just ask me after. I'll go through the algebra. That's how you FOIL. The denominator, don't simplify it. It's easier not to. What happens to the numerator? It gets simplified to negative x divided by 2x, 3 plus radical x plus 9. What could I cancel? Right, the negative x. There's two x's there. Good. Right, I was guaranteed from the beginning that I could cancel. So negative 1 over 2 times 3 plus radical x plus 9. Okay. What do I get for the final?
One over.
Listen. And I get negative 1 over 12. So 2 times 3 plus rad 9, negative 112. Good. Okay, any questions on this? Right, do you guys see how these are going to involve a lot of algebra? Right? I promised it. It's not because I promised it, it's just because I know what's in this course. So I was able to warn you ahead of time. Okay. Okay, any questions about this problem? Or in general about this section? Okay, so let's try another one. It doesn't look like this, but again, an algebra is gonna help us here. Limit as t goes to 5, 1 over t minus 1/5 divided by t minus 5. Now, if I plug in 5 into the numerator, what do I get? I get 1/5 minus 1/5 in the numerator divided by 5 minus 5, which is 0. So what do I get? 0 over 0. Okay, so that means there is some sort of algebra, right? There is some sort of algebra that'll work here. Okay. Yeah, so what's the algebra that you could do with fractions? Well, with fractions, you can get a common denominator. So 1 over t and 1 over 5, you could simplify it by getting a common denominator. Does anyone see what's the common denominator of 1 over t and 1 over 5? 5t. Yeah, 5t, exactly. T times 5. So try that. Get a common denominator to combine the fractions in the numerator. Okay, that'll help you. Multiply 5 and tt. Okay, so then if I combine with a 5t in the denominator, then I get 5 minus t. You guys see that? This is my new numerator. And then here, t minus 5. Now you could think of t minus 5 as like t minus 5 over 1. So you could actually simplify this. So here's a little trick from algebra. When you divide by two fractions, it's like multiplying by the reciprocal. So that's the same thing as limit as t goes to 5. So 5 minus t times 1, 5 minus t times 1 divided by 5t times t minus 5. Okay. So remember, a fraction divided by a fraction can be combined into one fraction. Another algebra trick. Okay. Now what could I do? I want to cancel t minus 5. I can't quite cancel because I don't have t minus 5 up here. I have 5 minus t.
We take -1 as common.
Yeah, like Sharful is saying, limit as t goes to 5, I could factor out the -1. So -1 times t minus 5, 5t divided by t minus 5. And now what? Is that reading?
Cancel T minus.
Right, now we can cancel t minus 5. And what do we get? Yeah, ready? What do we get afterwards?
Minus 1 upon 5t.
-1 over 5t. Now what?
Replace pi in place.
Put in 5, so you get -1 over 25. Okay, any questions about this? Questions? Okay. Did you guys see the algebra trick for here? So for here, how do we simplify the algebras? We had a bunch of fractions. So the way we did it is we just simplified the fractions to get one single fraction. That was the algebra. Now there is an advanced topic that you could use here, but it comes much later in the course. Has anyone heard of something called L'Hopital's rule? Okay, that means, how many of you have taken this Calc 1 before, like either in high school or here? Raise your hand if you have taken it. Like in high school, a lot of you? Or here? Okay, yeah, so for these, you're not allowed to use L'Hopital's rule, right? L'Hopital's rule, you need it for way more complicated things than this. Things that just with algebra, so you can't use it. Make sure you don't do that on the exam. Okay. If you don't know what it is, then good. Then you won't lose points. But if you do know, don't get tempted. You don't get any points for that because we're trying to learn the basics here. Okay. Okay, so that's one kind of limit. Let's see. Okay, what if this one's not, this one's a little bit tougher. So what if they ask you to do an absolute value limit? 7x plus 56 divided by absolute value of x plus 8. Okay, absolute value. Okay. So this, if you just plug it in, if you just plug in -8, then sure enough, you'll get 0 in the numerator. Denominator -8 plus 8 is 0. Absolute value of 0 is still 0. So still 0 over 0. Okay. Now this is a little bit tricky because you might be tempted to factor a 7, but you can't just cancel, right? Because x plus 8 is not the same as absolute value of x plus 8. Right? So those don't just cancel. Right, what you have to realize is that you have to cancel out the absolute values by using the definition. So the absolute value of x, just to remind you from pre-calc, it's equal to x, but only if x is positive. Right, if x is positive or x is greater than or equal to 0, absolute values don't do anything. Right, absolute values make things positive. But if x is negative, in order to make a negative number positive, you have to take negative x. You have to take negative x. Okay. So here, when we have radical x plus 8, well then it is x plus 8. But only if x plus 8 is positive, which means x is greater than -8. X has to be greater than -8. And it's going to be negative x plus 8 if x is less than -8. Okay. So in order to do a problem like this and get rid of the absolute values, you'll have to take the limits left and right. Limits left and right will tell you which side you're on for the absolute value to actually take a limit. So to actually do this problem, you have to do x negative 8 to the left. And now we'll actually factor out a 7. X plus 8 divided by radical x plus 8. I mean, absolute value of x. And here I'll need limit as x goes to negative 8 to the right. 7 x plus 8 absolute value of x plus 8. Okay, so what does that let me do? Well, first of all, a regular limit does look at left and right to check that it matches. But now that we do left and right, I could get rid of absolute values, because if I'm to the left of negative 8, right? So things like negative 8.1, negative 8.01, is the absolute value the first or the second function? Left of negative 8 would be which one? Right? Is it the first one where x is greater than or equal to negative 8, or the second one where x is less than negative 8? Right, it's the second one, right? Right, so if you're looking at numbers to the left, that means x plus 8 is a negative number. So then this is the limit as x goes to negative 8 from the left, 7 times x plus 8. But since x plus 8 now is a negative number, this will be negative x plus 8 for absolute value. Right? So this gets rid of absolute values for you. Okay. Right, left of negative 8 makes x plus 8 negative, so its absolute value is the negative version. Just so you could see the difference. So what about here? To the right of negative 8, if I'm greater than negative 8, x plus 8 is positive or negative? Matthew? Positive, right? X plus 8 are positive numbers. So if it's positive, the absolute value doesn't do anything. It's just x plus 8. Okay. So you have to know how the absolute value function works, depending on whether you're positive or negative. So x plus 8, if it's positive, then it's not there. Is there a question? Oh, how would you work out the answer? So remember, it's a 0 over 0 case. That means you could cancel. So let's see here. I have x plus 8 numerator, x plus 8 denominator, right? So what happens? They cancel. And if they cancel, what am I left with? 7 over negative 1. So it's just negative 7. Just negative 7. And what about here? I have x plus 8 over x plus 8. Cancels. This is x goes to negative 8 from the right. And it cancels. I'm just left with 7. Okay. Now, a regular limit asks if the left and right match. Do they match? Negative 7 and 7?
Oh,
Right. So all that work, the answer is D and E. Didn't have to be, but it is in this case. Yeah, so whenever you guys see absolute values, you'll have to work on either side of the absolute value to get rid of it. Otherwise, you won't be able to maneuver and do algebra with absolute values. You have to use that definition. Okay, any questions on this? Matthew, did you have a question? You had a question? Okay. Do you guys see how absolute values work? Okay, so let me show you how the WebAssign looks. Right, so we were doing 2.3. Okay. So like questions like number 1, right? It's like what we did. We just plug in the limits that they gave us, and we just get the right answer using those limit laws. Okay. Similar with number 2, but you'll just use the graph to figure out what the limit of f and g are. So like as x goes to 2 for f, so the Oh, what's the limit as x goes to 2 for f here? Right, what are the y values heading towards? -1, right. And what about limit as x goes to 2 for g here? What are the y values going towards? 2. So then it'll be -1 plus 2. That's right, it's 1. Okay. So did you guys see how to do this? Yeah, just use the graph to calculate each piece of the limit. Eventually they'll get to limit of 0 over 0. Yeah, so numbers 6 and 7 are like the 0 over 0. So try number 6 and 7. Your numbers might be different, so you could actually open up yours. Or if you don't have yours, you could just do mine, but then you'll have to tweak yours. This section makes sense with the 0 over 0s, like what you guys have to do. Okay, in terms of the algebra. If anyone wants me to check any of their work, I can come and check. See if you're doing it correctly.
이게 바로 댕기는 밑에서 집게 접어 Could you help me with this?
Okay, let's just sketch the graph. So then the first part is a line, the x less than -1, so you have to start at, plug in -1, you get 2. You have -1, 2. So you start at 2. This is just a line, positive slope like that.
Yeah, I understand it, but this part I don't understand.
Use the graph to determine where the limit does not exist. Oh, okay. So you got this graph?
No, this one.
Let's see. It's the right graph. Yeah, okay. So where does the limit not exist? Well,
I think mine -1.
exactly, -1.
Yeah.
Everywhere else it exists, like even at 1, the left and right matches up.
Mhm.
Everywhere else it's continuous, so only -1, left and right don't match. Exactly, so that'll be the answer, so
Like
Uh,
scales,
A equals -1.
scales up. Just need to- Not sure.
Good. Okay, were you guys able to get at least like number 6? Okay, does anyone need help with number 6? Yeah, Matthew?
What about number 7?
Number 7, yeah.
You want me to show it to you?
Yours, your numbers are a little different, yeah. This one, okay.
That's what I get.
Number 7.
This one.
So it's a trickier question. So then it's 4/0. Then that's the other section. So
With
then
the
you have to,
infinities.
with
now?
infinities, you have to check left and right for
Yeah.
infinities. Good. Yeah, so Matthew was pointing out, so number 7 is not so easy because if you put 6 in, it's not 0/0. It's actually a different number divided by 0. So what do we do for that? We have a different trick that we need. We have a different trick. Yeah. Exactly, the plus or minus infinity. But then you have to do limit left and right to see if it's positive, negative infinity and see if they match up. Since it's a full limit, you need to see if there's a match of infinity or negative infinity. Yeah, so I would say this is a trick question to put it in this section, just because this section we're used to 0/0, but it's not. So we do need infinity or negative infinity. Yeah. One thing I'll just point out for you guys is for questions 15, 16, and
16, 17.
yeah, just 15 and 16. Yeah, if you know how to do it, that's fine, but don't worry about 15 and 16 for now. I want to go through those next class just because it's a different topic. I don't want to start a new topic now. It's still part of the same section, but it's a different idea. So don't worry about 15 and 16 for now. Okay. And then the others are everything that we covered, so you should be able to do. So now, normally at this time, I would let you guys work on the homework, so you can like pile as much in for a half an hour to get all your homework done. But I actually have a meeting, so we'll have to end early. I know you're sad, don't be sad. Stop, hold it back, hold it back. Hold it back, it's okay. We're on camera, so.